we are going to look at systems of inequalities, which is when you have more than one inequality at a time. So we've done systems of equations when we have more than one equation, and we solve those with substitution and elimination. With the inequalities, in order to solve them, we are going to have to use a graph. So, if I asked you to graph the solution to this, both of these are just lines, because you have an x to the first, a y to the first. So we can graph them by getting it in the standard, y equals mx plus b form. So if I subtract over my x, I get y is less than or equal to, I'm going to write it as negative x plus 2. So I have to subtract over my x. So if I wanted to graph that, how do you graph a line? It's been a little bit. We have to start at our y-intercept, which is 2. Slope is negative 1, so down 1 over 1. Now, we're going to have to pay attention to a couple things here. You'll have to know if your line should be solid or dashed. How would we know the difference?
If it's equal to.
If it has an equal to, that means a solid line. If it doesn't have an equal to, that means a dashed line. So both of these have an equal to, so we're going to do just a solid line. So we'll draw that line in. And then, because of the inequality, we have to end up shading. So we'll have to figure out where to shade. So hopefully you guys can draw a straighter line than I can. It's not my strongest suit up here, but
Not one bit.
how do we know where to shade?
If
We got a
it's
test.
greater than 0.
So there's a couple options. I think Mrs. Keller usually had you do test points. So she had you pick a point that wasn't on your line. Most of the time you probably just did 0, 0 unless it was on the line. If you plugged a 0, 0 in, you get 0 less than or equal to 0 plus 2. So is 0 less than or equal to 2?
Yes.
Yes, that's true. So 0, 0 works.
So
That's below the line, so we shade below. Now this is actually not my final answer yet, so I'm only going to lightly shade this in for now. So on your paper, just lightly shade that. Now we have to do the second one. So it's again a line. Alright. So y is greater than or equal to negative 2x plus 4. So then if we graph that, we start at the y-intercept of 4.
down
Down to over 1. Solid or dashed?
to solid.
Solid. So I drew a mostly straight line there anyway. Alright, and then we have to figure out where to shade. So we can take a test point. As long as 0, 0 isn't on the line, it works. So that gives us 0 is greater than or equal to, 2 times 0 is 0 plus 4. So is 0 greater than or equal to 4? No, that is false. So 0, 0 did not work.
So it's on
So it's the other side of the line. So how do I get a final answer from here?
what is not shaded?
It's actually what got shaded by both of them. So the overlap. So that's why I had you lightly do the rest of it, and then you need to darken in the final answer. So when I look at your graphs, I should know what your final answer is. So it's just this section right here. That means any ordered pair I take in that green section makes both of those inequalities true. Some people like to erase the other shading at this point. Some people just color it in dark. Some people like to use a highlighter. I don't care as long as I can tell the difference between your final answer and the other shading along the way. All right?
That makes sense.
Okay. Do you guys remember doing these last year? Okay.
There's a lot of things that we've done this year. guys.
Two.
It's just extra crap.
Let's not do that one yet.
Why? 'Cause I can't really
Why don't you guys see? Well, let's take a look. What should we do first here?
subtract the x.
Okay. So if I take the first one, subtract my x, then what?
Divide the -2.
So when you divide by a negative, what happens?
It flips.
So -1 over -2 is a positive 1/2. 6 divided by -2 is -3. Oh my goodness, did I change my y to an x?
Yes.
I'm struggling, I don't know. You guys are right, I shouldn't have done anything today, huh?
We can stop right now.
Oh, you do that for me?
You can always go back.
Okay, so now I can graph this. Y-intercept is -3, so start at -3.
Go up 1,
Up 1,
right 2.
right 2. I'm gonna put a bunch of points because I can't draw a straight line otherwise. You only have to have 2 to get a line. Solid or dashed?
Dash.
Dashed because it didn't have an equal to. Okay.
0.
So if you have a test point, if you put in 0, 0, you get
It's true.
0 is greater than -3. Is that true or false? True or false?
True.
True. So 0, 0 works. Another easy way to tell where to shade, if it's a line, you can just look at your inequality. Greater than means above, so we would shade above the line. Less than means below, so you shade below. I don't care if you do it that way. You don't have to show me the work from a test point. So if you know that greater than will be above your line, that's great. You can go ahead and just shade above.
See, this
So for the second one, what do we do?
subtract 2 of it. So
And then we divide by -4, which flips my inequality. -2 divided by -4 is positive 1/2. So when I graph this one, what's my y-intercept?
0.
And slope 1/2, so up 1 over 2. Solid or dash?
Dash.
Dash because there's no. Yeah, they have the same slope. These lines are parallel.
So smart, so smart.
Okay, so can you tell me without picking a test
Yes.
point, where am I going to shade?
Below.
Less than is below. So final answer is the overlap, which in this case is in between those parallel lines. What if we had a scenario like that where we had 2 parallel lines, but let's say one of them shaded above and the other one shaded below?
No solution.
No solution. If they don't overlap, there's no solution, and that is possible. So we're not guaranteed an answer. So all this means is anything in that green area works for both equations. Okay.
Is it possible for 2 lines to be on each other?
Yes.
Wouldn't that be all?
If they end up being the same line, then it'll be like the entire
Yeah,
side.
hold on. How could it be all numbers if it's not really touching all?
How about, let's do one that's not linear. Because we've graphed lots of different functions. So we could do something like this. What's that first one?
A parabola.
A parabola, very good. So if you remember transformations, it's a parabola shifted down 4. If you don't, you can plug in some points. You know, if I put in a 0 for my x, we get out 0 squared minus 4 is negative 4. If you put in a 1, 1 squared minus 4 is negative 3. Put in a 2, 2 squared is 4, minus 4 is 0. You get the same thing when you put in the negatives. You just get a fraction. And you can do more points if you want. If you want to put in a 3, 3 squared is 9, minus 4 is 5. Just enough to kind of get the graph. Solid or dashed?
Dashed.
Okay. When it's not a line, it's not as easy to just look at it and know where you're going to shade, so we could easily do a test point here. If we put in 0, 0, we get 0 is greater than negative 4. Is that true or false?
True.
So if 0, 0 works, where am I shading?
Inside.
Inside. And then we do this one. So this one's just a line. Y-intercept negative 2, slope of 1, so up 1 over 1. Solid or dashed?
Solid.
Solid. Okay, so if I'm trying to decide where to shade, less than tells us
Right?
below.
Yeah, like anywhere.
So what's the overlap?
Right.
Little.
The little would, yeah, right there. That's what you.
Alright, so I'm going to give us 3 this time.
Oh.
Yeah, and that first one is a doozy, isn't it? Negative 4 less than x less than 0. Turn around, Eli.
I was looking at the
Mhm.
differential value.
Turn around. If I just said like x equals 3, how would you graph that?
It's a straight.
A vertical line at 3. If I said y equals 4, that would be a horizontal line at 4. If I say negative 4 is less than x is less than 0, what I'm saying is x is between negative 4 and 0. We know if it's x equals, it's a vertical line, so we have 2 vertical lines here, and we're talking about everything between them. So I have a vertical line at negative 4. It didn't have an equal to, so that's dash. I have a vertical line at 0, which is just the axis here. And I'm shading in between those 2 lines. Okay, if it had said negative 4 is less than y is less than 0, it would be in between 2 horizontal lines. All right, second one. What do I need to do to graph that? Okay, so that means y is greater than negative x plus 2. So start at 2. Slope is negative 1, so down 1 over 1. Solid or dashed?
Dash.
Okay, greater than means I am shading above. Less than is below, greater than is above. Or you could pick a test point if you weren't sure. So far, my overlap is this little section up here. Now, we now have another one. So we have to find the overlap between all of them. So this one, I can subtract over my 2x.
Whoa. Well, that's gonna
My y-intercept is 10. Slope is negative 2, so down 2 over 1. Okay. Solid or dashed? measure it solid, didn't I? Okay, less than means we shade below this. Alright, so sometimes it can look confusing when we have so many lines. If you need to erase some of your extra shading, you are welcome to do so. So we are in between the red and green lines here and in between the blue ones. So we are just looking at this little piece right here. Do we need more examples? You guys feel okay with this stuff? Where are we at?
Hope I'm not
I think
You think you're good? Okay, so I have a handout.
doing that.